In this tutorial, we will see how to compare multiple production facilities using locational cost-profit volume analysis. Locational cost-profit volume analysis only considers the fixed and variable costs for each location. The steps for performing locational cost-profit volume analysis are as follows. 1. Determine the fixed and variable costs for each location to be considered. 2. Plot the resulting total cost lines for each location on one common chart. Each will plot out as a straight line. 3. Estimate the expected volume and use the chart to pick the lowest cost alternative at the expected volume. The assumptions for locational cost-profit volume analysis are as follows. 1. The fixed costs for each location are constant for a reasonable range around the volume being considered. 2. The variable costs are linear for a reasonable range around the volume being considered. That is, the slope of the total cost line is constant. 3. The required output volume can be closely estimated. The closer the volume is to a break-even point, the better the estimate needs to be. 4. Only one product is involved. Before continuing, please take the time to review the break-even analysis tutorial in the basic calculations section, as these calculations build off of that. A company is considering 4 locations. The fixed and variable costs for each are shown on the slide. Plot the total cost lines for each location on a single chart. Identify the range of outputs for which each location has the lowest cost. Finally, if the expected volume is 10,000, which location should they select? The slide shows the 4 total cost lines plotted on a single chart. This was constructed using Excel. If you are creating the plots by hand, keep in mind that it takes only 2 points to determine a line. The first point would be at 0 volume, where the total cost just equals the fixed cost. Next, select a relatively large volume and compute the total cost for each alternative. That gives you the second point you need for each line. Using the chart, notice that location D is the cheapest at low volumes, something we would expect given it has the lowest fixed cost. There is an intersection at somewhere around 4,000 units and B becomes the cheapest. We know that because its total cost line is the lowest. Using break-even analysis between D and B, we find that point to be 3,571. At about 12,000, A crosses over and becomes the cheapest. Again, using break-even analysis between B and A, we find this point to be 12,500. So D is the cheapest from 0 to 3,571, B is the cheapest from 3,571 to 12,500, and A is the cheapest above 12,500. At some point, C may become the cheapest, but not within the range we are studying. The problem asks about 10,000 units, and at that range, B is the cheapest, so it should be selected. A company is considering 4 locations. The fixed and variable costs are each shown on the slide. Plot the total cost lines for these locations on a single chart. Identify the range of outputs for which each location has the lowest cost. Finally, if the expected volume is 1,000, which location should they select?
Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made.
The slide shows the 4 total cost lines plotted on a single chart. Using the chart, note that location D is the cheapest at low volumes. Location C crosses and becomes cheapest at about 600 units. Using break-even analysis between D and C, the point is exactly 600 units. A crosses and becomes cheapest at around 1,500 units. Using break-even analysis between A and C, the point is exactly 1,500 units. Thus, D is the cheapest below 600 units, C is the cheapest from 600 to 1,500 units, and A is the cheapest above 1,500 units. Since the company is expecting a volume of 1,000 units, they should select location C. If this video helped you working operations management problems, please consider liking the video and subscribing to the channel.